Good morning, students. We'll do some problems in the electric potential. Important problems we'll do. We'll start the problems. See this. A hexagon of side 8 centimeter has a charge of 4 microcoulomb each at its vertices. The potential at the center of the hexagon will be. So draw a hexagon. So this will be hexagon. So this will be hexagon. Hexagon means totally 6 sides will be there. At each side, 4 microcoulomb charge is placed. So here 4 microcoulomb, here 4 microcoulomb. At each corner, 4 microcoulomb charge is placed. Okay. Here 4 microcoulombs are placed. Then what they are asking is, what is the electric potential at the center? This will be the center. This distance will be equal to side from each corner. Distance to the center will be equal to side of the hexagon. So totally 6 charges are there. All are identical only. So V net value is equal to 6 are there. 1 by 4 pi epsilon naught. Potential due to a point charge. 1 by 4 pi epsilon naught Q by R. So that is the formula for it. So here what we will get here, see, here this value is equal to 6 into 1 by 4 pi epsilon naught value 9 into 10 power 9. Charge value 4 microcoulombs, 4 into 10 power minus 6. Distance will be 8 centimeter, 8 into 10 power minus 2. So if we calculate this one, 4, 2's will cancel, 2 will cancel here by 3 times. So this is 3 into 9, 27 into 10 power 5 will come here. So we will write like this. V is equal to 2.7 into 10 power 6 volt. So this will be the answer for it. Okay. Hexagon, 6 corners, 6 identical charges are placed. What is the potential at the center? So all are identical charges. All are at equidistant from the center. And if this is A, this will be also equal to A. Using that, we can do this problem. See the second one. A spherical shell of radius 10 centimeter is carrying a charge Q. If the electric potential at distance 5 centimeter, 10 centimeter, and 15 centimeter from the center of the spherical shell is V1, V2, and V3 respectively, what is the relation between them? Okay, there is a sphere like this. Okay, what is the radius of the sphere means that value is equal to 10 centimeter. This is the center of the sphere. So at 5 centimeter, next at 10 centimeter, at 15 centimeter. So 15 centimeter, this will be 5, surface will be 10, and the outside will be 15 centimeter. So what we know here is potentials are V1, here potential is V2, here potential is V3. What is the relation between the potentials? What we know here is potential will be same inside the sphere also. So on the surface, how much potential will be there? same potential will be there inside. And when a distance is increasing, what will happen? So if you are going away from the center, potential gradually decreasing. So this V1, V2 values will be equal, and that value will be greater than V3. So option for it will be fourth option. Okay. Next, understanding this one. Next, see the next problem. See, already I shared the questions for you. I will share. I shared already. In the totally 95 questions or something odd is there. 90 plus are there. We can't discuss all the questions because of the time constraint. I can't discuss all the questions. Important questions we will try to discuss. Okay, important and what you are feeling difficult. Those questions I will discuss. Okay, here what happened? First question I discussed. Second question, okay. Third question will be little bit easy. You do that one. If any doubt is there, you just WhatsApp me or call me. Will clarify that also. So in that, all questions are important. You should prepare all the questions. Some difficulty questions. What you are fear, what this will feel. I am feeling this is difficult. Maybe for the student. That type of questions I am discussing because of the time constraint. Okay. Next, what they are giving is the radius of two concentric conducting shells of radius R1 and R2. The two shells are there, two spheres are there. They are having radius R1 and R2. For example, it is a sphere having radius R1, R2, let it be. And one more is there, its radius will be, it is not coming properly. Okay. Here one more is there. Okay, like this. It is also going wrong. Two concentric spheres are there. Inner radius is R1 and outer radius is R2. They gave that. Inner radius is R1, outer radius is R2. The charge on the outer shell is Q. Charge on this outer shell is Q. The charge on the inner shell, which is connected to the ground. This inner shell is connected to the ground. What is the charge on it? Now, it is connected to the ground means its potential value will be equal to 0. Here on the surface of this, two potentials will be there. One is due to the charge on the inner sphere, another is due to the charge on the outer sphere. So this will be V due to inner and V due to outer is equal to 0. Inner charge we have to find 1 by 4 pi epsilon naught. I am assuming Q dash. This Q dash value I have to find. And this value 1 by 4 pi epsilon naught. This will be, these points will be inside the shell, inside everywhere, potential will be same and equal to the potential on the surface. So 1 by 4 pi epsilon naught Q by R2 is equal to 0. We can take 1 by 4 pi epsilon naught common and bringing to this side it becomes 0. So Q dash by R1 plus Q by R2 is equal to 0. So Q dash by R1 is equal to minus Q by R2. So Q dash is equal to minus Q R1 by R2. So this will be the answer for it. So what is the option for this is minus R1 R2 into Q. So fourth question, it will be first option. Okay, this is the answer for it. Okay, for each question solutions are there. Already I provided the solutions for each question. For tough questions, I am discussing once again, feeling that you people may not understand like that. Next, two concentric spheres are there, the radii R1 and small capital R and small r. Positive charges are there, Q1 and Q2, with equal surface charge densities. Electric potential at the center will be how much? So both are having the same surface charge density. So two spheres are there like this. Okay, what is the potential at the center? Because of the outer sphere, because of the inner sphere, potentials will be there. We'll calculate the charge. Q1 value is how much? Q1 is equal to surface charge density into area. So 4 pi capital R square. Q2 how much? This value sigma into 4 pi small r square. Next, soon we have to calculate net potential at the center. So due to the outer sphere, it will be there. Due to the inner sphere, it will be there. For both V1 and V2, 1 by 4 pi epsilon naught is common. So here Q1 by means sigma into 4 pi r square by radius r. And for this sigma into 4 pi small r square by small r. So what we will get here, see. So this is equal to 4 pi sigma, you take a common. Here 4 pi epsilon naught is there. And one RR will cancel here. Here R will remain capital R. Here also small r will cancel it. But there small r will be there. 4 pi cancels. This R and this one R. This R and here one R will cancel. So V is equal to finally sigma by epsilon naught into R plus R we will get. Okay. Epsilon sigma by epsilon naught into R plus R. So for this question also, first option will be the answer for it. Next. See the next question, what they are asking. Four charges Q plus Q minus Q minus Q are placed at the corners of a square of side 2L. The electric potential at capital A midway between the two charges plus Q and plus Q will be how much? Okay. Then how to do this one? So draw a square for it. Draw a little bit bigger square for your understanding. Here, what is this point means? This will be P. This will be Q. At Q minus small q is placed. At P plus small q is placed. And here, this will be S. This will be R. They gave in the diagram this one. Here minus q is placed. Here plus q is placed. A is the midpoint of plus q and plus q. Side length will be 2L they give. So this value will be L. PA will be L. And AS value. This value is also equal to L only. L. These distances. And from here we have to take this distance we have to take. And this distance from this charge. This will be how much? I must see, this is L. Na? This side will be 2L. So this distance will be root 5L. In the same manner, it is also 5L, root 5L, because this is L, this is 2L, hypotenuse will be root 5L. Then you calculate the potentials. V net is equal to, what we will get? V is equal to V1 1 by 4 pi epsilon not common here. So because of P, Q by L, because of Q minus Q by root 5L. Okay. Because of R, here what we will get? Minus Q by root 5L. Here again because of S, Q by L. So that is the net potential. Okay. And now net potential V is equal to 1 by Q also you take a common. L also you take a common in the denominator. So here Q by L if you take, here it will be 1. This will be minus root 5. It will be 1 by root 5. Here it will be 1. Okay. So how much we are getting here? See, I am writing here. V is equal to Q by 4 pi epsilon naught into L. 1 plus 1 will be 2. This will be 2 by root 5. So this is 2Q by 4 pi epsilon naught. 2 also we took a common. So this is 1 minus 1 by root 5. This is the answer for it. So 1 by 4 pi epsilon naught. L is also there, my dear. You write here L. 4 pi epsilon naught L. So 1 by 4 pi epsilon naught 2Q by L into 1 minus 1 by 5. So this will be the answer for it. This is the answer for it. Okay. See the next question. Here there is a cube having side B. There is a cube of side B and a charge Q at each of its vertices. Potential due to this charge array at the center will be. So draw a cube for your understanding. So there is a cube like this. Okay, here. Here, what is the potential? Cube is having totally 8 faces. Na? So V net is equal to 8 into 1 by 4 pi epsilon naught Q. Distance of each corner to the center will be root 3 by 2. The side is B. Na? So that's why it becomes root 3 by 2b. 4, 2 times will cancel. This 2 will goes to numerator. So 4q by root 3 pi epsilon naught into b. This is the net potential at the center. So what is the answer for this is this is the answer. So 4q by root 3 pi epsilon naught b. So this is the answer for that. Okay. Okay. Next, after finishing of this, see the next question. N small drops are there. They are made to combine to form a big drop. Potential of the big drop and potential of the small drops. Let's see what to do. Here N small drops are there. Here some small drops. All the small drops are combined to form a big drop. Okay. Each small drop is having a charge Q. Each small drop is having a radius R. Like this, N drops are there. All these drops are combined, a big drop is formed. I am assuming big drop charge is capital Q. Big drop radius is capital R. Okay. If you learn this too, then we can do any, they can ask the capacity, they can ask volume charge, whatever it may be, the things easily, you potential difference and whatever it may be thing, you can calculate easily. Then here see, what to do is all are combined according to charge conservation. Charge on the big drop is equal to charge on the n small drops. Okay. Next, volume of the big drop 4 by 3 pi r cube. Similarly, volume will also remains as the constant. So n into 4 by 3 pi small r cube. 4 by 3, 4 by 3 will cancel. R cube is equal to n into small r cube. R is equal to n power 1 by 3 into small r. This is the relation between the radius and the relation between the charge. Here, potential difference, what will happen? Surface charge density, what will happen? Potential of the small, how much? 1 by 4 pi epsilon naught. Small q by small r. Potential of the big is equal to 1 by 4 pi epsilon naught capital Q by capital R. This capital Q place, I am writing n into small q. Capital R place, I am writing n by n power 1 by 3 into small r. So this n by n power 1 by 3 means n power 2 by 3. 1 by 4 pi epsilon naught q by r. 1 by 4 pi epsilon naught q by r will be small q by small r will be v small. So v big is equal to n power 2 by 3 into v small. So this is the relation between potential of the big and potential of the small. Okay. Next, surface charge density. Sigma small. Charge on the small drop will be Q. Area of the small drop will be 4 pi r square. Sigma big, capital Q by 4 pi r square. Capital Q means n into small q. 4 pi, this value. Capital R is n power 1 by 3 into small r. So this value square is there, na? N power 2 by 3, small r square will come. N by n power 2 by 3 means n power 1 by 3. Q by 4 pi r square. So here what we will get is sigma big is equal to n power 1 by 3 into sigma small. So this is the relation between the surface charge densities. Okay. Like this, you can calculate capacity, you can calculate energy, whatever it may be the things, these two are important. Charge and radius. If you know easily, you can calculate the relation between the other. So here potential becomes n power 2 by 3. So second option, potential increases to n power 2 by 3 times of original potential. Charge density decreases to n power potential, how much? N power 2 by 3. And it will becomes n power 1 by 3. So this will be the answer for it. That is 16th question. Next, see the 20th. Here, just to confuse you, they will create something. There is a sphere like this. There is a sphere in this manner. Okay, one circular plate. This gap they left here, nothing is there. On this portion, they gave a charge to QQ. On this portion, they gave a charge minus 2Q. For this portion, they give a charge 3Q. Here there is no charge. This angle 45, this angle will be something like this. Up to this angle will be 45 means it will be 135. Total 180. So this angle will be totally 120. So for a portion of angle 45 degrees, they gave a charge Q. For a portion of angle 135 degrees, they gave a charge minus 2Q. For a portion of angle 120 degrees, they gave for this portion here to here, the entire. They gave a charge of how much? Plus 3Q they gave. Then what is the total potential at the center for this portion? They gave a charge of plus 3Q. For this portion, they gave a charge of this one, minus 2Q. And for this portion, they gave a charge of Q. Here gap, no charge. What is the net potential at the center? So no, formula, basic formula only, V is equal to 1 by 4 pi epsilon naught. Potential will be 1 by 4 pi epsilon naught Q by R. So 1 by 4 pi epsilon naught Charge on the surface, total charge, how much? Calculate. Q minus 2Q plus 3Q. So 4Q minus 2Q means it will be 2Q only. Okay. So this value here, it will be 2Q. Understanding? Total charge by radius. Why this is 2Q? Q minus 2Q plus 3Q. This is the total charge on the surface. Here gap is there. No need to consider everything. No need to consider that angles. Just to confuse you, they are creating all of this. So answer will be 1 by 4 pi epsilon naught. So V is equal to, we'll write one more step here. 2 will cancel 1 by, so finally here 2 by Q by 2 pi epsilon naught into R. So this is the answer for it. Q by 2 pi epsilon naught R. Okay. So that is about the 20th. Next, see this 22. What they are asking me. An isolated parallel plate capacitor of capacitance C. The four surfaces have charges Q1, Q2, Q3, Q4 as shown. The potential difference between the plates is what? Okay. Here, what is the concept is charges. On the inner plates of capacitor are equal and opposite, are equal and opposite. So what we will get here is Q2 is equal to minus Q3. Okay. Now, so here both charges will be same only. Okay, that is the concept. Now, what is the potential difference between the plates? What is the potential difference between these plates? So here V is equal to, both charges are same, so Q2 by capacity, they gave it as V is, so PD between the two plates will be Q2 by C. But here in the answers, Q2 by C is not there. So we'll write like this one. I am writing it as 2Q2 by here 2C. 2 I multiplied and 2 I divided. 2Q2 na I am writing it as Q2 plus Q2 by 2C. Can we write like this? Yes, we can write. Therefore, V value is equal to here. V is equal to Q2. But what we know, Q2 is equal to minus Q3, we know. So 1 Q2 place, I am writing minus Q3. But this Q2 is there, na? This one, this Q2. Because of this Q2, I am writing instead of that minus Q3 using this formula. Q2 minus Q3 by 2C. This will be the answer. So here for this will be the option, third option. Q2 minus Q3 by 2C. Actually, answer will be simple and direct only. V is equal to Q2 by C only. But to confuse you, they are creating all this. So Q2 minus Q3 by 2C will be the answer for this 22nd question. Next, see the 25th question, what they are asking. A large solid sphere with uniformly distributed positive charge has a smooth narrow tunnel through its center. A small particle with negative charge initially at rest far from the sphere approaches it along the tunnel, along the of the language. It is along the tunnel, reaches its surface with speed v and passes through the tunnel. Its speed at the center of the tunnel is what they are asking. See, here there is a sphere like this. This sphere is having one tunnel at the center. Here one hole is there like this. Here they made one hole. Like this, they made one hole. Okay, far from it means it is falling from infinity. Like that we can take. Here one particle is there. Charge minus Q. Okay, that is falling, freely falling, that is. It is falling like this. When it reaches here, its velocity will be v. When it reaches here, let its velocity is v surface. This is vs. You take here center. Let it be, take it as vc. It will passes through the tunnel. Na? When it reaches to the center of the tunnel, what will be its velocity? That is the question. Large solid sphere is there. Charge is uniformly distributed on its surface. Particle is falling. When it reaches to the surface, its velocity is v. This vs value, they gave it as v here. When it reaches to the center, what will be the velocity? That is the question. Okay, we'll calculate the potentials. We'll write the potentials. Potentials. V infinity, it is falling from infinity distance. Far means infinity. At infinity, potential will be 0. On the surface, potential capital, this is not small. On the surface, 1 by 4 pi epsilon naught Q charge, capital Q, it is having, like that I am assuming. Here surface on the sphere, charge is distributed on the surface only. A solid sphere with uniformly distributed positive charge. Uniformly distributed means it is totally distributed, not on the surface here. Total charge will be Q. It is totally, entirely distributed means this will be non-conducting, like that we have to take. Next, potential at the center of non-conducting sphere will be 3 by 2, 1 by 4 pi epsilon naught kq by r. These are the formulae. Okay, potential at the center will be for non-conducting sphere. If it is conducting, okay, same only there. Non-conducting means 3 by 2 kq by r. Now, from infinity to surface, work done is equal to change in the kinetic energy, 11th standard work energy formula. So here velocity will be 0. Here velocity will be V. Work done is equal to W is equal to VQ formula. So here charge is minus Q, V infinity minus V surface is equal to half mv square. Initial kinetic energy is 0 because it is freely falling. So here V infinity will be 0, minus into minus plus. How much we will get here is Q into this Vs value will be K capital Q by R is equal to half mv square. Make this as equation 1. Okay. Yes. Next, from infinity to center. Okay, you can't expect simple problems here in the NEET examination. What will happen? This is all India wide competition. First thing, one medical seat in the private colleges will be around 1.5 crore will be there. I know this much only. You ask in this only. I know charge. I know radius. Calculate the potential on the surface. You give this one. Like that, they won't give. Understanding? But from the past 2 years, 2019, 2020, questions will be simple questions only. Direct and theory questions, simple questions only they gave. Here also, this year also, we are expecting due to the corona, same simple questions they will ask like that, I am thinking. So, but whatever the models in the chapter, all models we will prepare. Question paper is easy, will be so in competition, competitive examination, there is no question of difficulty or simple. Simple is easy means everybody it is easy. Difficult means everybody it is difficult. Like that it will be there. So here from infinity to center, what we can write here is minus Q V infinity minus V center. Honestly, again here why we see everything. You already here one we are using. You use here V1. Here directly they gave. Here directly you assume and they gave here that is V is equal to half m V1 square minus 0. So minus into minus plus Q 3 by 2 KQ by R is equal to half m V1 square. This will be equation 2. You divide 2 by 1, do 2 by 1. K capital small q capital Q by R divided by 3 by 2 K small q capital Q by R. No, we wrote wrong. Reverse, 2 by 1 we are doing. So here 3 by 2 will come is equal to here half m V1 square by half m V square. This one will cancel, half m will cancel. So how much we will get here? 3 by 2 is equal to V1 square by V. V1 square is V square. This is 1.5 V square. V1 is equal to 1.5 root 1.5 V. Okay. So root 1.5 V will be the answer. So 25 fourth option will be correct. Whatever the models are there, you prepare all the models. Okay. Next question. What they are asking, see, 2-point charges, 100 microcoulomb and 5 microcoulomb is placed at the points A and B respectively, with AB is equal to 40 centimeter. Work done by the external force in displacing the charge 5 microcoulomb from B to C, where BC is equal to 30 centimeter, angle ABC is equal to pi by 2 is. So what they are asking here is, there is a triangle like this. Equilateral triangle. Here, pad is little bit skipping because when we are drawing the vertical lines, because friction is less. Then see, here A, B, C. This is A. This is B. This is C. A, B, C. And BC length will be 30. AC length will be 40. Obviously, hypotenuse will be 50 centimeter. Here at a charge of 100 microcoulomb is placed. At B, a charge of 5 microcoulomb is placed. We are moving this 5 microcoulomb from B to C. What is the work done? Work done is equal to change in the potential into charge. W is equal to V into Q. V is potential difference. Potential who will create this 100 microcoulomb will create. Because of this 100 microcoulomb, at B how much potential is there? At C how much potential is there? You calculate. From that we can find the work done. Okay. So potential at B 1 by 4 pi epsilon naught Q by R basic formula, like 10 power 9, 100 microcoulombs. Distance is 40 centimeter. Okay. This 0 will cancel. This is a 9 by 4 into finally 10 power 6 will come here. 9 by 4 into 10 power 6 volt. And because of A, here how much potential? We are moving this charge. So no need to consider this 5 microcoulombs. Vc is equal to 1 by 4 pi epsilon naught Q by R formula, 9 into 10 power 9, 100 into 10 power minus 6 by 50 centimeter distance. So this value 9 by 5 into 10 power 6 volt. Okay. Now potential difference between A and B is how much? Work done. Work done is equal to Vc minus Vb into, we are moving that Q2 charge. Vc value will be 9 by 5 into 10 power 6 minus 9 by 4 into 10 power 6. We are moving 5 microcoulomb charge. 5 into 10 power minus 6. This 10 power 6 taking common, 10 power minus 6 will cancel. 9 also you take common. Here 5 is also there. 1 by 5 minus 1 by 4. So 9 into 5 into 4 minus 5 by 5 into 4 LCM. 5 will cancel. So this will be minus 9 by 4 joules. So what is the work done here means W is equal to minus 9 by 4 joules. Okay. So answer for this will be this one. Fourth option will be the answer. Okay. Next, 27. Here, equipotential surfaces are there. Here they are straight. Here little bit curved. Here spacing is more. Here they are curved like this. A charge is moved from A to B. Here, here, and here. Where more work will be done? Work done is independent on the shape of the equipotential surfaces. Work done is equal to, what is the formula? W is equal to delta V into Q. Potential difference is same only. Whatever it may be the shape, potential difference is same only. From 10 volt, it is moving to 40 volt. Here, what is the voltage? 10. Here, what is the voltage? 40. Here also 10, here also 40. So say under the same potential difference, it is moving. So work will be same since delta V is same in all, work is also same. So what will be the answer for it means in all the 4 cases, work done will be the same. That is 27. Next, 36 you see. 3 charges are placed at the vertices of an equilateral triangle. Net potential energy, how much? This will be simple only. So there is a triangle like this, equilateral triangle. Now here 3 charges are placed. Change the color. Here a charge Q. Here a charge Q. Here a charge Q placed. What is the potential energy of the system? What is the formula for potential energy of the system? U is equal to 3 charges are there. 1 by 4 pi epsilon naught Q1, Q2 by R12, Q2, Q3 by R23 plus Q3, Q1 by R31. Okay. So this value will be 1 by 4 pi epsilon naught. Q same only. This will be Q square by L. This will be Q square by L. Q2 all are same Qs only. This is Q square by L. So finally U is equal to 1 by 4 pi epsilon naught 3Q square by L. Okay. This is the value we are getting. Next, 39 you see. Okay, we'll stop the session now. We'll continue the remaining in the next class. Okay.